Hey guys, welcome to another maths tutorial. In this video, I'll be going through the circle theorems. I'll also do examples relating to each circle theorem. Let's get started, guys. So I'll first go through the circle vocabulary so that you're able to remember the different parts of the circle. Here I have the circumference. That's a diameter there. That's radius. That's a chord. And that's a segment there. That's a tangent. That's an arc. And that's a sector. Now let's look at the first circle theorem. Angle at the center is twice angle at circumference. And what this really means is that, for example, if I label that angle there y, which is at the circumference, it therefore means that the angle at the center here would have been twice that, which would have been 2y. So now let's look at an example involving this theorem. Find the missing angle. So in this case, the angle at the circumference is 50 degrees, which therefore means in order to find the angle at the center now, which is y, I would have to do 2 times 50 degrees, and my answer would have been 100 degrees. So y is equal to 100 degrees. Now let's look at an example involving this theorem. Find the missing angle. So in this case, we're trying to find angle x. We can see that there is an angle there in a semicircle. So that angle would have been 90 degrees. And we also know that the sum of the interior angles of a triangle sum to 180 degrees. So what we can do now is basically to add that 90 degrees plus 55 degrees and take it away from 180 degrees. So that's 180 degrees, take away 145 degrees, which therefore means angle x is now 35 degrees. Now let's look at our third theorem. Again, this is still linked to the one that we did first. So this is the theorem that we looked at before, which we said that angle at center is twice angle at circumference. So we're going to use this one now to help us to come up with the other theorem, which is the third one. So look carefully at what I'm doing now, guys. If I draw another angle in my circle there, you'd agree that that angle there at the circumference would have been y as well, because we said that angle at circumference would have been half the angle at the center, subtended by the same arc, which therefore means that that angle is also y, which gives us another theorem which states angles subtended from the same arc are equal. Now let's look at an example involving this theorem. So the question reads, A, B, C, and D are points on the circumference of a circle O. AC is the diameter. Angle DAC is equal to 42 degrees. And that's the diagram for the question. It's not drawn to scale, so again, please do not use your protractor to try and measure to find the missing angles. It says, write down the value of x and work out the value of y. If you notice, part A of the question, it says write down the value of y, which therefore means there are no calculations involved. Okay, so look carefully at it, guys. Remember what we said, angles subtended from the same arc are equal, which therefore means that this angle here, this 42 degrees, would have been exactly the same value as this missing angle that I don't know, which is x. So x is also 42 degrees. Okay, then it says work out the value of y. Now I'm trying to find y, which therefore means I'm using that theorem that speaks about angle in a semicircle is 90 degrees. So that angle there would have been 90 degrees. Again, the sum of the interior angles in a triangle is 180 degrees. So I know that the angle is 90 there. I also know that this angle is 42 degrees, so if I add those two and take it from 180 degrees, I would have gotten my y. So that's 42 degrees plus 90 degrees would have given me 132 degrees. So I do 180 degrees, take away 132 degrees, and my answer is 48 degrees. So my missing angle y there would have been 48 degrees. Now let's look at another theorem, guys. Look carefully at what's happening again. So this is the one that we looked at previously. So we said that this angle is y, which therefore means that the one at the center now would have been 2y. We agree with that. Also, think carefully now, guys. If I want to find this angle here, it would have been 360 degrees take away 2y, because we know that angles at a point sum to 360 degrees. So if this angle here is 2y, this missing angle, which I don't know, must be 360 degrees take away 2y. So again, this angle would have been 360 take away 2y, which therefore means this again is at the center. So the one at the circumference now would have been half that value, which now becomes 180 degrees take away y. Lovely. So let's look at what's happening now, guys. If we look at this 180 degrees take away y, if I should add this angle here with this angle here, which is my y there, I would have gotten 180 degrees take away y plus y, which leaves me with 180 degrees. So the sum of these two angles will give me 180 degrees. So those two angles that I label would have given me 180. Also, those two angles now in blue would also give me 180 degrees, which therefore means that Theorem 4 states opposite angles in a cyclic, or some people say cyclic, quadrilateral add up to 180 degrees. So it's really easy theorem to remember that once it's a cyclic quadrilateral, opposite angles will sum to 180. And what that really means, guys, if you notice, there is a quadrilateral inside of the circle, and all four vertices are touching the circumference of the circle. So that makes it a cyclic or a cyclic quadrilateral. Now let's look at an example involving this theorem. Again, we have this question: P, Q, R, and S are points on the circumference of a circle. It's not drawn to scale. We're asked to work out the size of angle X, which therefore means, we just said it earlier, we said opposite angles in a cyclic or cyclic quadrilateral sum to 180 degrees. So it therefore means that this angle, which is 124 degrees plus X, must give me 180 degrees. So what do I need to do is therefore do 180 degrees, take away 124 degrees. So my X is 56 degrees. So that missing angle X is 56 degrees. Now let's look at another example involving this same theorem. So it says, the diagram shows a cyclic quadrilateral. Work out the value of y. I love this question, guys, because it gives you the opportunity to use your algebra skills. Now, we know that these two angles, y as well as 4y, must sum to 180 degrees. So I write y plus 4y is equal to 180 degrees. And all I'm doing now is applying my algebra skills to solve a simple equation. So y plus 4y gives me 5y, and that still equals 180 degrees. I'm solving for y. The y is being multiplied by the 5, so it therefore means I divide both sides of the equation by 5, which gives me my y to be 36 degrees. And again, if you're asked to write your reasoning in the exam, all you need to write: opposite angles in a cyclic quadrilateral add up to 180 degrees. Now let's look at another theorem. So we spoke about the radius, and we also spoke about the tangent here. So here we have this representing the radius. We also have a tangent, and what we need to know is that that radius as well as that tangent, they meet at 90 degrees, and that's also a theorem So the radius and tangent meet at 90 degrees. Now let's look at an example involving this theorem. The diagram shows a circle, center O. C and D are points on the circumference. COE is a straight line. DE is a tangent. Again, it's not drawn to scale, so please do not use a protractor ever to try and find a missing angle. Work out the size of angle Y. So it therefore means that what I know so far is that angle there at the center would have been twice the angle at the circumference. So the angle there at the circumference is 25 degrees, which therefore means that the angle at the center would have been 50 degrees. What I also know is that the radius and the tangent meet at 90 degrees. So that angle there is 90 degrees. And the next thing that I'll use to help me now is the fact that the sum of the interior angles in a triangle sum to 180 degrees. So if you realize that I'm trying to find a missing angle now in a triangle, I already know this angle to be 50 degrees. I also know this angle to be 90 degrees. So it therefore means I can easily find my missing angle Y. So I add 50 degrees plus 90 degrees. And then I get 140 degrees. I take that away from 180 degrees and I get my Y to be 40 degrees. Now let's look at another theorem which basically states tangents which meet at the same point are equal in length. So what this is saying is that if you have two tangents from the point that they touch the circle to where they meet, they are equal in length. Okay? So let's look at a question involving this theorem. ABC is a chord of the circle. TA and TB are tangents to the circle. And again, we would agree that TA and TB, they are tangents to the circle, which means that we know that they would have been equal in length. Work out the size of angle X. So look carefully at what I'm trying to find, guys. I'm trying to find angle X. And I know that TA as well as TB, they're equal. And here you realize you're seeing a triangle, which therefore means that if we have a triangle that has two equal lengths, it now becomes an isosceles triangle. So I can use that information to help me to work out the missing angle. Okay, so that angle must be X as well, we agree, which therefore means that if I take 38 degrees from 180 degrees, whatever is left, all I need to do is divide it by 2 to find my missing angle X. So I do 180 degrees take away 38 degrees, and I'll divide that by 2. When I take away, I get 142 degrees, and I divide it by 2 now, which therefore means that my X would have been 71 degrees. Now let's look at our final theorem for this video, alternate segment theorem. So here I have a chord, and here I drew a tangent. If I complete a triangle inside my circle, this angle between the chord and the tangent is equal to this angle that's on the opposite side of the triangle inside my circle. So the angle between the tangent and the chord is exactly the same as the angle inside the triangle on the opposite side, which therefore means if I draw another angle there, it also means that this angle would have been equal again to those two that I have already. Also, this angle here in green, that's between the chord and the tangent, would now be equal to this angle here, which is on the opposite side in the triangle. Now let's look at an example involving the alternate segment theorem. This question, it says write down the value of X and give a reason for your answer. So again, this question, it says write down, which therefore means there are no calculations involved. Again, it's the alternate segment theorem, which therefore means that angle x would be equal to this angle, which is 43 degrees. So my angle x would have been 43 degrees. And again, the reason that I would write is that angles in the alternate segment are equal. Now let's look at an example involving the alternate segment theorem. So this question, it states, P, Q, and R are points on a circle. Triangle PQR is isosceles. XY is a tangent to the circle at P. Work out the size of angle RPY. So my first step is really to identify the missing angle that I'm trying to find. Where is it? So RPY. So I label it. So that's the angle that I'm trying to find. But before I can find that angle, sometimes I might have to find other angles first before I can get the one that I really need. So I'm going to use all that I know to help me. So far, they told me that it's an isosceles triangle, which therefore means that the base angles in an isosceles triangle are equal. So this angle must be 35 degrees as well. We also know that the sum of the interior angles in a triangle adds to 180 degrees. So I can find my missing angle there. So I do 35 degrees plus 35 degrees, that would have given me 70 degrees. I take that from 180, I get 110 degrees. So that missing angle there is 110 degrees. Okay, the next thing that I know is that angle RQP, the one that I just found to be 110 degrees, so angle RPQ, which is this angle here, would have been equal to angle RPY, so this angle I'm trying to find. And how do I know that? Again, we mentioned that the angle that's formed between the tangent and the chord would have been exactly the same as the angle inside the triangle on the opposite side, which would have been this 110 degrees. So therefore means that the angle I'm trying to find, which is RPQ, is 110 degrees. Now let's look at an exam style question, and this is the last question for this tutorial. So the question, A, B, C, D, and E are points on a circle. AC is parallel to ED. Write down the size of angle X and work out the size of angle Y. Again, it asks you to write down the size of angle X, which means that there are no calculations involved. So I'm trying to find this angle, and again I realize that these angles would have been exactly the same, because that's the theorem that talks about angles subtended by the same arc would have been equal. So this angle X would have been 70 degrees. Work out the size of angle Y now. So my first step is really to find that missing angle there. And how can I go about finding that missing angle? Is the fact that, look carefully at what's happening, guys. If I look at this line here, AC, it's parallel to DE, which therefore means that I'm also seeing this line, which would have been like a transversal there, which means that this angle here, which is 34 degrees, would have been exactly equal to this angle, which we don't know. So this angle is also 34 degrees. And the reason for that is alternate angles are equal. And what do I mean by alternate angles? It's really basically angles on the opposite side of the transversal, which are in the same segment, alright? So that's also 34 degrees, alright? So now I'm trying to find this angle here, which would be quite useful as well. So again, we know that opposite angle in a cyclic quadrilateral sum to 180 degrees. So if I know that this one here is 70 degrees, the one that's opposite to it must have been 180 degrees. Take away 70 degrees, I get 110 degrees. Lovely. Now I have more than enough information to find my missing angle Y. Again, I'm seeing that I'm trying to find a missing angle in a triangle. The sum of the interior angles in a triangle add to 180, so it's easy for me to find that y now. So now I need to add 110 degrees plus 34 degrees, and then take that away from 180 degrees, or I could just simply do 180, take away 110, take away 34, and now my y is equal to 36 degrees. And that's it, guys. Please, if you haven't subscribed yet to my channel, please do so and hit that notification bell so that you're notified when I post new videos. Like and share this video. Thanks for watching, guys.